Talking Trees with Lily and Jad. In today's episode, we'll be discussing Adbian, a software tool designed to assist arborists in evaluating tree stability. This innovative tool uses 3D modeling and data analysis to determine whether a tree is safe or if stabilization measures are necessary. It supports arborists in making informed decisions on whether to remove, stabilize, or leave a tree untouched. Let's explore how Adbian is revolutionizing tree stability assessments and decision-making in arboriculture.
All right, so let's jump into this deep dive about evaluating tree stability.
It's a fascinating topic.
Especially for those of us who, deal with trees on a regular basis.
Right. You want to make sure they're not going to fall over on you.
Exactly.
Or on someone's house or anything.
Yeah.
So, we've got a lot of great material to cover today.
I know. I'm really looking forward to this.
Get this. What if I told you that up to 32% of recommendations to remove trees could be dead wrong?
Yeah. That's a lot.
That's a lot of trees.
Yeah.
Facing the axe unnecessarily, and that's what we're deep diving into today. So let's jump right in.
Yeah.
This system, it's really interesting because it's not about replacing your expert eye.
Right.
You as a tree professional, you go out there, you look at the tree, you get a feel for it.
Mm-hmm.
But this system is about adding data and analysis to what you already do so well.
Yeah, and I think that's what's really key here is that it's not just about intuition anymore.
Yeah,
right?
Totally.
It's about actually having some hard data to back up those gut feelings.
Absolutely. Yeah, and sometimes the tree is just deceiving.
Oh.
Like it looks strong and mighty on the outside.
Totally.
But on the inside, it might be, compromised in some way.
Yeah.
So the system helps us to really get a more complete picture of the tree's health.
Yeah, I like to think of it as kind of like getting a medical checkup for a tree,
Right.
You get all those tests done, you're getting all the data points, so you can really make an informed decision about how to care for it.
Yeah, that's a great way to put it.
Yeah, so tell me a little bit about how this 4-level system actually works.
So it starts with, the basics,
Okay.
What we call level 1, which is, kind of what you're already doing, visually assessing the tree. But it's more systematic, right?
Yeah.
So instead of just looking at it and being like, oh, that tree looks healthy or that tree doesn't look healthy, you're actually taking measurements, recording data points, things like the species of the tree, its height, its diameter. And all of this data kind of gives you a baseline understanding of the tree's stability.
And that's level 1. Right?
That's level 1. That's our foundation.
Okay, so what kind of information do we actually get out of that level 1 assessment?
So the key output from level 1 is what we call a safety coefficient.
Okay.
And this basically tells you how likely the tree is to withstand strong winds based on those observable factors that we just talked about.
So it's giving you a numerical value that represent the tree's stability. Okay, that makes sense.
But it's important to remember that this coefficient is based solely on those external factors.
Oh, okay.
So it doesn't tell us anything about what's going on inside the tree.
Right. So it's like looking at the cover of a book, but not actually reading the story. Right?
Yeah, exactly. You got to dig a little deeper to really understand the whole picture.
So that's where those higher levels come in, right?
Exactly.
They start to give us a more in-depth look at the tree's condition.
Yeah, we start peeling back those layers.
Okay, so tell me, what's the next step in this journey? What's level 2 all about?
Level 2 is, we call it Dendrology Plus. And this is where we start incorporating calibrated photographs.
Ooh, okay. So we're getting a little bit more technical here, a little more high-tech.
Yeah, exactly. So we're not just looking anymore. We're actually using technology to capture more precise data.
So we're not just relying on our eyes anymore. We're actually bringing in some tools to help us.
Right.
Okay, that's interesting.
And the real power of this level is that it allows us to track changes over time.
Oh, okay. So it was like having a time-lapse view of the tree's growth and movement.
Exactly. We can use those photographs to analyze things like the lean of the stem and any asymmetry in the crown.
So it's like having a series of snapshots that allow you to see how the tree is changing.
Exactly.
Over time.
And, subtle shifts that you might not notice with the naked eye.
Right. And those subtle shifts could be like early warning signs of a potential problem.
Exactly.
Okay, so we've gone from basic measurements to incorporating photographs. What's next?
So level 3 is where things get even more exciting, at least from a technology standpoint.
Okay. Oh.
This is where we introduce 3D scanning.
Ooh, 3D scanning. Now we're talking.
Yeah.
I can already see how that would like revolutionize our understanding of the tree structure.
It does. It really does.
Yeah.
With the 3D scan, we can capture the intricate geometry of the tree trunk in incredible detail.
So we're talking about like every nook and cranny, every bump and curve. Okay, so it's like having a virtual tree that you can examine from every angle.
That's a great way to put it.
Yeah, that's pretty cool.
And this level of detail allows us to do some very precise calculations of the tree's biomechanics.
So you're not just looking at the tree's structure, you're actually simulating how it will behave.
Right.
Under different conditions. That's amazing.
Exactly.
That's incredible.
And that's incredibly valuable for making, informed decisions about tree care.
Yeah, absolutely. Absolutely.
But, even with all this technology, we still haven't talked about the inside of the tree.
That's true.
Right. All of this has been focused on the external structure, but we know that internal decay can be a major factor in tree failure.
Right. That's like the silent killer, right?
Exactly. And that's where level 4 comes in.
Okay.
This is where we finally get to peek inside the tree.
And see what's going on.
Exactly. So we're talking about tools like sonic tomography.
Okay.
Which uses sound waves to create a map of the internal wood density.
Okay, so we're bringing in the big guns.
Yeah, bringing in the big guns.
Yeah.
Yeah, and this allows us to see things that would be impossible to detect with the naked eye.
Right. So it's giving us that deeper understanding of the tree's condition.
Exactly.
Wow, this is all really fascinating.
Yeah.
I'm already starting to see how this system could really change the way we approach tree care.
Absolutely.
So we've got level 1, the systematic upgrade to our visual assessments.
Right.
Level 2, which incorporates those calibrated photographs. Level 3, with the 3D scanning.
Yeah.
And then level 4, where we're really getting at those internal diagnostics. This is a pretty comprehensive approach.
It is.
Yeah.
It's a comprehensive and a data-driven approach.
Okay, so now I'm really curious to dive into those individual levels in a bit more detail.
Yeah, let's do it.
Let's start with level 2, maybe,
Right.
and talk about how those calibrated photographs can really reveal some subtle changes in a tree structure over time.
Let's get into it. Yeah, so, with those photographs, like I mentioned, it really gives us this cool ability to track those changes in the tree structure over time.
It's like having a time-lapse view, almost.
It really is, yeah.
Of how that tree is growing and moving.
Exactly. So let's say you've got a mature oak, right, that you're assessing, and it's got a slight lean to it.
Okay.
Now, just from looking at it, you might not know if that lean is a recent development or if it's always been there.
Right, because it's just a snapshot in time, essentially.
Yeah, right, exactly. But
you don't have that historical context.
With level 2, we can go back and look at photographs taken over several years, and we can actually measure how much that lean has changed.
Oh, wow.
If at all.
So you're not just relying on, your memory or anecdotal observation.
No.
You're actually bringing in a hard data
right.
to track those changes.
Hard data, yeah, and that can be so revealing. Let's say we see that the lean has been steadily increasing over time.
Okay.
That could be a sign of root problems or soil instability.
It's like a slow motion warning sign that something might be wrong.
Exactly. Okay. And then on the other hand, if that lean has remained pretty much the same over the years, then that gives us more confidence in the tree's stability.
So it's not just about identifying potential problems.
Right.
It's also about gaining a deeper understanding of the tree's history and how it's adapted to its environment.
Absolutely. And that historical perspective is so valuable for making those informed decisions.
Right.
About how we care for that tree.
It's not just a static thing. It's
not static.
It's constantly changing and adapting.
It's always changing, yeah.
Okay, so we've covered level 1, the systematic upgrade to our visual assessments. Level 2, incorporating those calibrated photographs to track changes over time. Now I'm really curious to dive into level 3, the 3D scanning.
All right, let's talk 3D.
What can you tell me about that?
So with level 3, we're basically creating a digital twin of the tree.
A digital twin? That sounds pretty futuristic.
It is pretty cutting edge, but it's becoming more and more accessible to arborists and tree care professionals.
Okay.
Essentially, a 3D scanner uses lasers or other imaging techniques to capture millions of data points on the surface of the tree.
So it's like taking a super detailed photograph, But instead of capturing light and color, you're capturing the actual shape.
Exactly.
Or dimensions of the tree. And from those millions of data points, we can create a three-dimensional model of the tree that's incredibly accurate.
Okay.
And detailed.
I can already see how that would be so beneficial.
Yeah.
For assessing complex structures like trees that have cavities.
Right. Absolutely. You think about a tree with a large open cavity. Just by looking at it, it might be really hard to determine how extensive that decay is.
Right.
Or how it's affecting the overall stability.
You might see the opening, but you don't know how deep it goes.
Exactly. Exactly.
Or what the internal structure looks like.
But with the 3D scan, we can actually see inside that cavity.
Oh, wow.
We can measure its dimensions. So you're getting a much more complete picture of the structural integrity.
A much more complete picture, yeah.
Of the tree.
And not just for cavities. It's also incredibly useful for assessing trees with those complex branching patterns.
Okay.
Especially those that have like unusual growth forms.
Yeah, it can be hard to get accurate measurements of those kinds of structures.
Which can be really challenging, yeah.
With traditional methods.
Yeah.
Okay, and that precision allows you to do what?
That precision is what allows us to do some very sophisticated analysis of the tree's biomechanics.
Okay, I'm intrigued. What kind of analysis are we talking about here?
So with that 3D model, we can actually simulate how the tree is going to respond to different forces.
Okay.
Like wind or gravity.
So you're basically creating like a virtual wind tunnel.
Yeah, like a virtual wind tunnel.
Or putting the tree through a virtual stress test.
Exactly.
Well, that's really cool.
And this type of modeling can be so valuable for identifying those weak points.
Okay.
Or predicting how the tree might fail.
Oh, wow.
In extreme conditions.
So you're not just assessing its current condition.
Yeah.
You're actually forecasting its future behavior.
Exactly. And this predictive capability is what makes 3D scanning such a powerful tool for proactive tree care.
Right, because you can identify those problems before they even happen.
Before they occur, yeah, and take steps to mitigate them.
Okay, this all sounds incredibly powerful, but I have to ask, this level of technology, this level of analysis, it seems pretty sophisticated.
Yeah.
Is this something that's accessible to the average arborist?
That's a great question.
Or tree care professional? And
it's a question that's being addressed as we speak. 3D scanning technology is rapidly evolving. It's becoming more affordable and user-friendly.
So you're saying that this isn't just a tool for, like, researchers?
No.
Or large tree care companies?
No.
This is something that smaller businesses or even individual arborists could potentially use.
Yeah.
It's exciting to see how technology is making these advanced assessment techniques more accessible to a wider range of professionals.
It's a game changer,
yeah,
for sure. And as this technology continues to evolve, I think we're going to see even more innovative applications in the field of tree care.
So we've gone from basic measurements to calibrated photographs to 3D scanning.
Right.
What's the next step in this journey?
So level 4.
Towards a truly comprehensive understanding of tree stability.
Takes us beyond the external structure.
Okay.
Into the hidden world of the tree's internal condition.
So this is where we finally get to peek inside the tree.
Exactly.
And see what's going on beneath the surface.
We're talking about tools like sonic tomography.
Okay.
Resistograph, and even pulling tests.
So we're bringing in the heavy hitters here.
The heavy hitters, yeah.
Yeah.
And each of these tools provides a unique perspective on the internal condition of the wood.
I'm ready to unpack this. Let's start with sonic tomography.
Okay, sonic tomography.
How does that work?
So it's a non-invasive technique that uses sound waves to create a map of the internal wood density.
So it's like sending sound waves through the tree and listening for echoes.
Exactly.
Or changes in the signal.
Changes in the signal. And by analyzing those changes, we can identify areas of decay, cavities, or cracks.
So it's like giving the tree an ultrasound.
It's like an ultrasound for trees.
Okay.
And just like with an ultrasound, it allows us to see things that would be impossible to detect with the naked eye.
So it's providing valuable information about the structural integrity of the wood, even if there aren't any visible signs of decay on the surface.
Exactly.
Okay, so sonic tomography gives us a picture of the wood density.
Right.
What about the resistograph?
Okay, so resistograph measures the resistance of the wood to penetration.
Okay.
So essentially, it drills a small needle into the tree, and it records the force required to push that needle through the wood at different depths.
So it's like taking a core sample?
Kind of like a core sample, yeah.
But instead of removing a chunk of wood, you're just getting a continuous reading of the wood's density and resistance.
Exactly. And this allows us to detect subtle variations in the wood strength and identify areas that might be compromised by decay.
So it's a more detailed and localized assessment.
More localized, yeah.
Of the wood's condition compared to sonic tomography.
Right.
Which gives you more of a broader overview.
A broader overview, yeah.
Okay, great.
And both tools have their strengths and weaknesses.
Right.
Sonic tomography, great for that big picture view.
Okay.
Resistograph is better for pinpointing those specific areas of concern.
Okay, so we've got sonic tomography, resistograph. What about pulling tests?
All right, pulling tests.
How do they fit into this level 4 assessment?
So pulling tests are a more dynamic way to assess the tree's stability.
Okay.
We're actually attaching a cable to the tree and applying a controlled force to simulate wind load.
So you're putting the tree through a mini windstorm.
In a way, yes.
To see how it responds.
But it's very controlled and carefully calibrated. Yeah. We're using sensors to measure the tree's movement and deflection under those different loads. And this data lets us calculate the tree's overall stability and its ability to withstand wind forces.
So it's not just about looking at the wood's condition.
No.
It's about actually assessing the tree's structural performance.
Exactly.
Under real-world conditions.
Under real-world conditions, yeah. And this can be particularly valuable for assessing trees with complex structures or those that have been weakened by decay or injury.
So by combining those pulling test results with the data from sonic tomography and resistograph, you're getting a really complete picture.
A complete picture.
Of the tree's health and stability inside and out.
Inside and out. That's the power of level 4.
Yeah.
It brings together all those previous levels of assessment, and it adds that critical layer of internal diagnostics.
Wow.
It gives us the most complete understanding of the tree's condition possible.
This has been an incredibly insightful journey.
It has.
To the 4 levels of tree stability assessment.
Yeah.
I'm already seeing how this system can really revolutionize my own approach to tree care.
Absolutely. It's a game changer.
It is. It is.
And as we've seen, each level builds upon the previous one, adding those layers of detail and insight that allow us to make more informed decisions about tree management.
Well, on that note, I want to thank you for sharing your expertise with us today.
It's been my pleasure.
This deep dive into tree stability assessment has been truly illuminating.
Glad to hear it.
And to our listener, thank you for joining us on this journey of discovery.
Yeah, thanks for listening.
That's it for today's episode, where we explored how Adbian is transforming the way arborists assess tree stability. We hope you found this look into 3D modeling and data-driven decision-making insightful, especially when it comes to deciding whether to stabilize, remove, or leave a tree. Thank you for tuning in, and we truly appreciate your continued support. We'll be back soon with more discussions on the latest tools and techniques in arboriculture. Until next time, keep growing your knowledge and taking care of the trees around you.